Lucky with Indiana Chapter, American Concrete Pavement Association. I'd like to welcome everybody. My role, as far as concrete's concerned, is on the pavement side, and I'm an advocate for concrete pavement. Also, I focus on technical support, so if anybody needs something, I'm the person to contact as far as pavement concerns are related. And this could be design, it could be maintenance, it could be end-of-life options. A lot of times, one thing I get involved with quite a bit is I've got a city engineer, he's got a pavement that's been out there 50 years, and they're looking for ways to maintain it. That's a good thing. You typically go out and say, typically go out and tell them, yes, you could patch. You might get to the point where if you have too much patching, it might be time to replace it. But then I try to explain, hey, you at least got 50 years out of it. Go ahead and do what you can. But I've seen a lot of pavements that have been patched, remain in service. Road outside of my house, it's been there 50 years, and they were able to patch it, and I figure it's going to add about another 20 years to that pavement. So if there's any question, field them through me as far as pavement's concerned. I've got a network of national resources. If I don't know the answer, I can get you that answer. So.
I got one too. Thanks, John. My name is Chad Montgomery. I'm the Executive Director of the Indiana Ready Mix Concrete Association. Very similar to the Pavement Association, where they focus on pavements. We focus on anything else that's related to ready mix concrete. So, and like John and IMAA and APAI, we're a resource to you all for free, that if you run into any issues out there in your day-to-day, we can help with design, we can help with all kinds of stuff. I've been doing this 10 years and have yet to tell somebody, no, we're not going to help you with that project or that issue. So we're here for you. Want to thank INDOT and the rest of our partners in this room for having us out here and letting us be part of the day. And with that, we'll turn it over to, I think, Mike. So.
All right, I don't have Calvin standing, so I'm not going to ask for applause. I'm just going to ask that you refrain from throwing anything, please, at any point during the talk. Talk about 1L cement. Wouldn't be concrete without talking about 1L concrete placements. E5 memo changes and the resonance meters that we've been talking about. Before I get started, I also want to mention that we do have some new folks in the office in my section at M&T. Those of you who don't know, Rick Harris was with us a long time. He passed away late 24. And we now have Elena Cruz. She handles a lot of the approved list items. Joe Romanek, he's handling the precast certified programs. And we have Brian Wathen, who was formerly the ME materials engineer in Seymour District. And then we have I call him Doctor, he's not here, Dr. Abul Mazumder, who's handling a lot of the kind of in-house research we're doing. I'm sure Rick is smiling somewhere and just laughing, saying it took 3 engineers to replace him. So if you know Rick, I think that's fair. So 1L cement. I'm a customer at this point. Not really trying to be mean here, but this is kind of how I feel. A little bit. There's been some marketing things in the past that some notorious ones, I guess. I was around for the Coke and the Zune. Don't really remember the Edsel, but you see where I'm going. The things are not as they were advertised, and I'm not particularly just being mean with this. The reality is it's being said out loud. If things didn't work out, maybe the first thing you do is change the marketing. On the left, you can see what was being said in 21. And this isn't just me talking. They know that, say perhaps it was a misstep. It was all type 1L cement was marketed as 1-to-1. It is not 1-to-1. That is being said out loud now. In IRMCA in 21 was saying it was 1-to-1. Now there's very carefully qualified language saying not so fast. And then in last year, ACI, Concrete International Magazine, there was this article where they said, while early promotional materials touted PLC as one-for-one replacement for OPC, field observations and subsequent work have indicated that the changeover is not that simple. And then, for example, additional limestone PLC can impact admixture effectiveness. These are things we've kind of been chasing, asserting, and trying to, suspicioned, and they're just, it's reality. And speaking of reality, this is our reality. It's happening. We're seeing issues. We're seeing cracking, scaling. Maybe not every time, but these decks, we're out looking at them now. Things from, we've got bridge decks from 23-ish. There was a lot of change very quickly, and we're seeing bridge decks rated 5s, 6s, quite a few 5s and 6s in the decks that are only a couple years old. There's at least 1 4 I'm aware of, and that's just not acceptable. Now, when this 1L came along, we also started machine grooving decks. Those two things kind of happened at the same time. The bottom left picture and the bottom right picture probably have a little more to do with the transition to grooving, in that grooving doesn't hide anything. When we tined decks in the past, there was a lot of, perhaps some forgiveness in that, in the texturing. But when you groove it, it's got to be about tabletop level to get even grooves. And then when the pans go back and forth, you inevitably get ridges. And in the bottom over here in the bottom, your bottom right, when the snowplows go over, they clip those ridges off. So there's some things out there that are being called scaling that are really, I would say they're scraping, which is a different phenomenon, and that's part of this. When everybody's looking at decks, there's a lot of different phenomenon going in play, and it's a little hard to sort out everything that's going on. Well, too much. So one thing that is going on, it's been a little bit of taking some time to sort this out, is that the idea that admixture incompatibilities are happening. Now, some people take offense at the term, honestly. To me, incompatibility simply means it's not doing what I expected it to do. That's my version of it. Maybe the chemists have a different version. But it's a fact that admixtures always needed to be really more customized to the cements that they're being used with. The fact is the chemical companies would rather sell one size fits all in a region. So the admixtures, especially the water reducing admixtures, were perhaps in recent history never dialed in the way they should have been, but they were good enough. There was a lot of experience with them. People knew how to use them, and made it work. There was a lot of change very quickly when the chemistries of 1Ls changed. The reality is that there wasn't a lot of communication between the admixture companies and the cement manufacturers. So things happened. We've seen a lot, we've had a lot that's happened, but now we're finally seeing it under the microscope. What you're looking at there is what we're calling air clustering. This is actually not a new thing. It's happened 20, 25 years ago. It happened with some other things, but that air clustering, I think it's a phenomenon between the water reducing admixtures and the cements, some of the chemistries in some of the cements. And the problem is it's not every time, everywhere, every cement, every time. There's a lot of variables, but those air bubbles tend to cluster around the aggregates. And one of the first things we started seeing was we test a lot of flexural strength. Well, when we tested flexural strengths, we started getting lower strengths, slower strengths, and a lot of aggregate pullout. And that was a lot of confusion about what was going on. There's still issues, but one of them we're pretty sure of is this air clustering effect that impacts the bond between the paste and the aggregate. Now, the air void systems also tend to be wonky, I always say that, scientific term there, but they're not well spaced, well distributed, and there's essentially maybe a foaming effect. We've seen some jobs where they are actually gaining air on the job site, but I'm also seeing this weird phenomenon there in the bottom right where usually the hardened air is actually a little lower. We've seen hardened air that's actually higher, which is unusual, which means that some of this air is actually being gained maybe after it's being tested. But there's air gain, and then the top one is even more interesting in that what you're seeing there is those air voids should be spherical. But more and more with the 1L cements, they're seeing these irregularly shaped air voids. And what I'm being told is that what the hypothesis is these are not single air voids. What's happening is multiple air voids, these spherical bubbles, are conglomerating together. So one of those irregular voids might be 4, 5, 10 smaller bubbles that are jammed together, and that shouldn't be happening. So the bottom line here is if folks are still seeing low strengths, slow strengths, let us know. We still need to gather data and try to figure out more about what is in fact happening. So, and as always, include the mixed design if you've got it. Picture on the left was taken just a couple weeks ago. That's a 23 deck. The picture on the right is a 23 deck. The one in the middle, south side of Indy, is a south of Indy is I think those are all 23s. And then the aggregate pop on the wall there is unusual. Typically, not picking on the aggregate folks, but it's not uncommon that we would see chert. You get a piece of chert, you get a single pop, water gets in, it weakens that aggregate, and you'll get that pop. It is odd that we are seeing pops like this, where you've got multiple aggregates that are actually fractured through, and things are popping off. That's not normal. So I guess the ask is going to be look at the decks, look at, and I will qualify here. A lot of what I'm talking about is bridge decks right now. Seeing less certainly in pavements at this point, but I think there's a lot of variables at play. So anyway, these are some of the things we're seeing. It's certainly not what we want to see. And if you're seeing these things, as you go out and look at decks, if you looked at them last year and thought maybe you were going to see something, please go out and look again. We are trying to do our best to go out and look. But send pictures that represent the whole thing. And then the mixed design and years placed, all that information is good to have. So one thing we have done is Indiana did cap, or INDOT did cap the limestone percentage at 10%. ASTM allows 15%. Look, the industry, they've said it themselves. I'm not picking on them. They're capitalists. It's more profitable to put more dust in there. So that's where they were headed. Some had kind of gravitated more back towards 10%. Others were going higher. But we've capped it at 10%. It was based on what we knew last year, and this really started happening early last year. Based on what we knew, it was a lever to pull. It's a step in the right direction. Is it going to solve everything? No, it is not. It's a step in the right direction, but there are a lot of variables at play. There's a lot of chemistries, there's a lot of things with the manufacturing itself, but limiting the limestone dust is very likely going to help the problem. So we are the only state in the country to have done that. It has not been without a bit of a challenge, we'll say. And anyway, that is in place. So any limestone cements, PLCs you get off of our approved list as of now are going to be capped at 10%. Concrete placement. So, I'm not picking on anybody here, and the intent is not to say no one got out of bed in my career and said I'm going to go do a bad job. I've grown up in this, as well, and learned some things. And the reality is 1L has highlighted some of the problems that are out there that we could have always been doing better. It's just there's a much narrower window for success with 1L. I don't think that's any secret for people out there working with it. So everything's got to be better. But the reality is there were some things we probably could have been doing better all along, but now we know. The other thing that's happening is that the 1L problems, whether they be finishing or wherever they are, I mean, these are compounding on top of those other things. The bleed rates tend to be slower. There's a lot more fineness in those cements. So more fineness means more surface area. The bleed water comes up more slowly. That changes the timing for the finishers, creates challenges for them if they're not on top of it. Changes the timing for the admixtures. It's just, these mixes are just less tolerant of water in general on the surface. And then and I mentioned before, the machine grooving, it's just, finishing's got to be better and flatter in order to get a good grooving job. So what else are we going to do to fix it? Certainly been said before, Insanity's doing the same thing and expecting something different. Culture and industry has got to change. I mean, there's some cultural things at INDOT that need to change in the way we do things, for certain. Again, there's things I've grown up in, and I'm going to talk about a few of them, but we can do better all the way around, and that's what 1L has really shown us, I believe. So we're learning, and some of the things I'm going to share with you are a few of the things that we think we need to fix, for sure. And there is a draft spec that was shared with industry back in December. It's still up for discussion, I guess. But one of the big thing, and I say now I'm from the 1900s, I'm feeling like an old dog, but performance versus prescriptive mixed designs. INDOT's mixed designs, talk about something that needs to change. Our prescriptive 700 mixed designs, look, they should have been left in the 1900s for sure, but here we are still using them. Most entities have moved to prescriptive or performance-based mixes. We actually do a better job with this on the paving side. They do better optimizing and QC/QA on that side of the fence, where they do a better job with, say, pushing for performance. Where the recipe side of the 700 mixes, our mixes were never very good. They're 658 pound of mixes. Not going to pick on the aggregate guys too much, but most of our 8s that we use with our concrete aggregate is gap graded for various reasons. So we're just saying use an 8, use 658 pounds of cement, it'll be all right. It really never was a good recipe, but we got away with it, I guess, for years with type 1 cement. It's really not working, and we were already, even before 1L, we knew we needed to head in the direction of performance mixes, but some other initiatives have gotten derailed. The last 2 or 3 years have been a whirlwind. So changes for deck and overlay placement, I'm going to talk about a few more of those, and then new equipment requirements. Keep in mind, as it says in red there, none of this is actually passed. Everything I'm about to tell you, however, though, is generally good practice. Even though it's not written in black and white in our spec, there's really no argument among ACI or various good practice things out there that these are still the right things to be doing. And one thing that I know INDOT has allowed, we've stood there and watched, and it's not everywhere, it's not every time, but there were a few contractors who were perhaps notorious for this, but steel floats, steel trowels should never be used on exterior air entrained concrete. They should have never been used on our bridge decks, but apparently some contractors, for one reason or another, they used them. Our folks were not trained to look for it and pay attention to it, and we didn't really know the why. 25 years ago, no one ever told me why you shouldn't use steel. It shouldn't have taken this long for us to figure this out. And again, everybody's not doing it, but the issue is that it might slick up the surface, or they might glide over the surface and make it smoother. The bad news is it traps that bleed water in that needs to still come out. And if you seal that surface up too tight before the bleed water finds its way out, it's going to scale. And it can also do things with the air void system and line up bubbles and create some delaminations. The steel is used commonly in your interior concretes, warehouse floors and such, where they aren't air entrained. It's not a problem there. They always hard trowel and steel trowel warehouse floors. but it's not the appropriate thing for bridge decks. Now, I'm told that a lot of what happens, or some of what has happened, is folks might come out of a union hall. They're taught some things, but they aren't told whether they're going to an exterior bridge or whether they're going to go to a commercial warehouse. And they show up with steel tools, and if the contractor doesn't know, tell them not to use that. Anyway, I think there's some cultural things. Now, there's one contractor I'm fully aware of that they just believed in it, and I think they used the steel. And all I can assume is we could have done better all along. Type 1 was forgiving enough, they got away with it, but we should have really never been doing it. Magnesium, aluminum, or composites, what you're looking for. The best inspection tool I would say on this is a magnet. Our inspectors should really have a magnet on them and just check. If they see, this is not spelled out in our spec right now, but no one's going to tell you that's good practice. So there's no reason why anybody at INDOT, or anybody, frankly, anybody should be doing it. Screed changes. There's a few things that have come to light. The 1L mixes certainly have behaved differently behind the screeds. Even the E5 mixes before the 1L came behaved differently. But I think it's come to revelation, we're over vibrating the surfaces too much. The bidwells have a vibratory unit on there typically that I'm going to start saying we need to shut it off. You don't need to remove it, just don't use it. When you're in the Gamecos, if you still have one of those older machines, they don't have it on there, I do not believe. So there's enough surface vibration for the drums and the rollers and the augers. We don't need more on the surface. The burlap drag, it promotes more touching of the surface, and it also promotes inevitably somebody wanting to stand off to the side and spray water on it every time it comes across. So you don't need more water on the surface, it's not helping. So I don't really think we need the burlap at all anymore. This is something that, honestly, talk about culture. I grew up in it. I'd never seen this done any other way until we started looking outside ourselves, and Kansas specifically puts this in their spec, but it's when whoever the labor is with the spud vibrator, when the mud hits the deck, the pump pumps it out there, the first thing. The guy with the spud vibrator walks around and vibrates it, and then everyone else steps forward and goes up with the lutes and starts doing their job, but they're stepping in it after it's been vibrated. It's been said, look, if you're stepping in it after it's been vibrated, it's no longer vibrated. You've got a footprint, you got voids, and now it's unconsolidated again. So paying attention to that type of thing. I honestly, when I read that and someone brought it to my attention, I can say I've never seen a bridge deck done where this has honestly been followed. I wasn't taught that, and I don't think it's just not in our culture to do it. So, how do we get around it? You've got to pay attention to it. The way Kansas spec calls it out is using gang vibrators. There's a much tighter operation to the screed, where some of them, I've got more pictures here, but some of them are, you vibrate it, and then the guys with the lutes or the laborers are behind it, so they're reaching over, and it's just a much tighter operation to keep from inevitably walking through it. Now this is one where a contractor got sophisticated, and I'm not expecting this, I'm just showing an example of maybe where it could go. But they got completely automated here, and a gang of vibrators, and to lower them down, and you're getting uniform and consistent vibration throughout with this. You can see how tight that is. I don't think I've ever been on a pour that looked that tight. It's gonna help. There's a lot of other things going on, but this is certainly something that can help. Now, maybe the more low-tech way to do it would be with a walk bridge and manually, 3 vibrators, lowering those down, again, and then the labor's not stepping in it. This one, they got one individual up on a walk bridge with a counterbalance, lowering 3 of them down, 3 or 4 of them, but the problem is the laborers are in front of it and between it, so they've got the timing of it out. But anyway, I'm not really asking for, the most sophisticated. We need to try. It's one thing that's been brought up that we can do better. Let's just try to do better with that. Leveling, now this is something that actually does have language in the current specification, but it's something that INDOT really has not enforced it. I think maybe 30 years ago this was done more, but I think we've gotten out of the habit. It was coming to light even before 1L, more with the machine grooving was bringing to light we needed to do better with the trueness and the smoothness behind the screeds. And in order to achieve that, we need to do more leveling. The paving folks you do this all day, every day. They got to get flatness, and they've got a 16-foot straight edge out there, and they're checking it all the time. We don't really do that as much on our bridge decks now. So we need to start. There is language in 70405 that says lay the straight edge out there and check it. What we need to do is check it all the way across. If there's low spots, fill them in. And if there's high spots, you're going to clip them off. And like I say, that language is actually already in the spec to some extent. Now, likewise with the bull floats, all these operations, we don't want to be over touching the surface. There's a certain amount of things you've got to do, but if the mix is proper, it should just be 1 or 2 passes. It's not keep running that thing across there and having to keep doing it over and over and overworking the surface by any means. The one issue certainly on bridges, especially phased bridges, is whether it be the straight edge or the float, you're going to have a long handle that's going to go somewhere. Is it going to be sticking out in an adjacent lane? Is it, how do you deal with it? We got to figure out how to deal with it. There are other types of tools that maybe used more in the commercial side, warehouse floors, but we've got to figure it out because this is what's we need to be doing it to ensure we get a smoother, flatter deck. And then like I said, no burlap. So I get rid of the burlap and we'll at the very end of the line do this light texturing, no different than we would do on a sidewalk or something like that. You don't want to pull the aggregate, dislodge the aggregate, but it's just a very light broom for a little bit of texture. Now this is going to be the tricky part. See if I can get to get out and get to the video. But no water applied to the surface for any reason. There is a approved list with a few true finishing aids on there. They're all colloidal silica based. We're going to use them in as packaged condition. Day one is one of the products. It comes in a dilutable packaging where you can dilute it, or a green bucket where you use it as packaged. The only thing we're going to allow is the stuff that's as packaged. I don't want contractors out there figuring out, well, I can stretch it a little further, use a little more water. We're not going to mix it on site. So all those products on the list are prepackaged. Use them as is, and you can rub on them. They're not going to be detrimental like the old evaporation retarders that were 90% water, and finishers thought they were doing better when they used that. Well, all they were really doing was rubbing water into the surface if you rubbed on it. You had to spray those and leave them alone, but I've seen more than one survey from other states go around, everybody says the same thing. Yeah, they work, but no one uses them right. And then absolutely we don't need no pressure washers. They put out way too much water. It's just a candidate for abuse. People are inevitably going to spray the surface, and we've got to get away from that. Every contractor doesn't use them, but there's a few of them that do. And we can't have this, whether they're spraying the mat there or whether they're actually spraying the deck. It's too much water. So I'm going to try to see if I can get down here to these videos. So this is a different video, but than what I was talking about pushing water, but this is one of these things that never happens until a video shows up, and it did happen. So this was a deck. It was raining. Obviously the contractor got caught and then decided to solve a problem by squeegeeing out the water. Inevitably, we have seen a fair amount of scaling in the gutter lines. This is obviously should not happen, but it did. Don't let this happen, right? But the gutter lines, water curing or whatever, inevitably with 1Ls, the more water laying in those gutter lines early on, the 1L just won't tolerate it. So the other video, if she can get to it, is actually showing, it's an overlay, and it's kind of showing them pushing the water out of the way, displacing water. I mean, on an overlay hydro demo, right, you've got to keep it wet, the surface wet, but then you've got to have it low spots. Well, that's going to be too much water for the 1L, and you're going to hurt the water cement ratio. Those low spots and those things have just got to be, they got to be blown out. We've all seen this done, and we're so, again, I talk about culture and teaching people to do things differently. We're just going to have to do things differently with 1L. It just doesn't tolerate it. But again, it was probably never great, but inevitably we've got to stop doing certain things that we've just seen done forever. I just said all that, water, don't do those things. And in the end, look, video, everybody's walking around with a phone in their pocket. A little bit of video goes a long way to answer a lot of questions and actually end a lot of arguments, I guess, for lack of a better word. It ends a lot of debate over what happened. We can spend thousands of dollars at Purdue sometimes. We run out and take cores and look for difficult answers and try to guess and what happened. And sometimes the simple answer was, yeah, nobody mentioned there was rain. So curing, the timing for applying the water curing, I do believe, is different with the 1Ls. You can't get on them as quick. One of the things I was going to take out was the language, the 60-minute window. When you get those hoses turned on, putting the burlap on, it's got to be well drained. You can't be dripping water. I've been in rooms with presentations by other folks, and they'll, the old paint brushes and splattering water, and they'll tell you that, yeah, if you get that water droplet, you're going to see where you've weakened the water cement ratio, and you'll see it. Well, you certainly can't be out there with dripping water off of burlap and all that. You got to have well-drained burlap, get it on quickly, but you don't want to get the hoses on there too early, because I think, especially on the overlays where we have been water curing over the past few years, you get the water in there. Our bridges don't have drains in the shoulders anymore. The water's got to run off the end. So if you get the hoses running, and now you get too much water laying in the gutter line somewhere, if there's a duck pond, which inevitably there is. I mean, sometimes it's hard to get those vertical curves to drain. When that happens, I mean, some of that water, even from the curing water, is just going to lay there in the gutter lines under the plastic, and I think that's not good either. So it needs a little more time before you start applying curing if you're going to go that way on a deck. We never stopped water curing the overlays. If opting out of E5, people have theories on things. They're going, some want to stop using the E5 as much as they have in the past. But due to, theories about 1L and what's causing some of our trouble. But just know there's a fair amount of forgiveness that comes with the E5. It does hold the water in, it doesn't leave. So there's the potential for experiencing more shrinkage cracking with a lot of other things going on and the fineness of the 1L. So, one thing when you take the E5 out, you got to put the other pozzolan in. So you take E5 out and you put in 30% slag cement. Well, I think a lot of what's happening is you're diluting the cement, right? Now you have 30% less 1L in there. And I think that might be as much of an effect as what we're seeing as a true improvement from, in some folks' minds of removing the E5. So we're still learning. It's going to be some challenges ahead. And anyway, that's kind of where we're at with it. Along the lines of E5, I don't have anything to change yet other than because I don't know where the spec's going to shake out. There's some things in the spec that's still being discussed, and I'm probably going to take out there's a line in there that says no excessive vibration. I'm going to probably take that out as far as the spud vibration goes and leave that, more to the contractors. But other than that, I still need to have more clarity on where we're going with the memo. It's just, the reality though is E5 never was built to fix certain things, maybe to their own, maybe they shot themselves in the foot a little bit. honestly, because I think people believed it was a silver bullet for a lot of things. It does do a lot of favorable things, holds the water in and makes a better placement and a lot of things out there in the real world. It's not going to fix fundamentally bad practices. It's not going to fix a bad mix design, which again, INDOT gap graded mixes aren't necessarily ideal, and those admixture compatibility things that could be going on under the hood with the water reducers and other things, it's not going to fix those. Lastly, the resonance meter that I've been talking about now, we started developing this thing in 2017, and there's been a lot of research. COVID happened. There's been, seems like, starts and stops with it. For you, those of you who don't know, what this is a sensor developed through JTRP research projects and Dr. Luna Liu at Purdue. It's her company, WaveLogix, but they're now marketing this product as it determines in-place compressive strength, independent of the mix design, and it's not like maturity where you have to do a correlation or any of that. It's just a boom, there it is answer. But we're going to make this more mainstream this year for the first time. We did a little bit of shadow testing last year on a couple jobs. We're going to, likely via Memo, we are going to invoke like 3 different USPs, one for structural, one for paving, and one for patching, and it's going to allow this as an option. We've still got to figure out some of the logistics, whether it's going to be paid by change order. I think that's the way we're going, but we've got a few things to sort out. But you are going to see this come out fairly soon. At this point, I'm probably going to say it'll be published in, I would hope for the end of March, but it'll probably be April when we get something out there to allow this in lieu of the flexural beams. I don't think anybody's going to shed any tears if they don't have to do any testing beams. So this will hopefully allow us a better way, I guess. And the beauty of this is the contractors and us, everybody has access to the dashboard. You can see in real time the strength gain and what's happening. And there's just a lot more information to be had. But for that, the contractors, I think there'll be a lot of wins here for us. So anyway, there's more to learn with that, and there's going to be a learning curve, but we are going to really get started this year with it. So with that, any questions?